Hello, we're gonna work on a physics problem with parallel plate capacitors. I posted the details info of the problem below the video if you want to pause the video and copy it so you can have it for later reference. Roughly, the sum up of the problem is the following. A parallel plate capacitor has a capacitance of 0.4 microfarads. The problem is asking us to find the charge. If the volt is 12, then it's asking us the charge net on both of the plates. Part C is asking us for the area of the capacitor, and the last part is asking for the electric field. So, the first part, we're gonna calculate the charge, and our first equation that we're gonna use is gonna be Q equals CV. Charge equals capacitance times potential difference. Here we are interested in the Q, so we can go ahead and plug our information in right away. 0.400 microfarads times 12 volts. Our charge is equal to 4.8 microcoulombs, sorry. And the problem was also asking us to find the charge in microcoulombs. And there you go. That's our first answer. Second question, find charge net on the capacitor. Well, if we look at our capacitor, we can see that on this side, the positive side, we're gonna have positive 4.8 coulombs, microcoulombs of charge, and on this side we're gonna have negative 4.8 microcoulombs of charge. So our Q net will be positive 4.8 microcoulombs plus the other side, which is negative 4.8 microcoulombs. And therefore our charge net equals 0. And this will be always true for parallel plate capacitors. On the charges on the two sides, they will be equal to each other, and they will be always, the charge net will be always 0. The third part, we're gonna calculate the area. The area, these are, let's say, square like this one also, and we are interested in this area right here. So for this area, we're gonna use a different formula. We're gonna use this one, where the capacitance is equal to E naught, which is the permittivity of free space, times area over distance, and the distance is the distance between the two plates. So from here we're gonna solve for our A, which is the area, equals capacitance times distance over E naught, and all we have to do is plug in. Our capacitance was given 0.400 microcoulombs times the distance is also given. Distance is 0.1 millimeters, but we have to convert this one to meters. So 0.1 times 10 to the negative third meters, and divided by E naught, the permittivity of free space. This is a constant, so that one is 8.85 times 10 to the negative 12 coulombs square Newton meters squared, the units. So our area, if we calculate this, will be 4.52 meters squared. This is our third answer. For our fourth question, for the electric field, first we're gonna make sure that our electric field is uniform, and parallel plate capacitors, it is uniform. This is how our E field goes between parallel plate capacitors. Therefore, and we're gonna use this equation where the potential difference equals to the electric field times the distance. Here we're gonna solve for our E, that's what we're interested in. Volts over distance, and all we have to do is plug in 12 volts divided by our distance, which the same as before, 0.100, but in meters, so times 10 to the negative third, and our E is equal to 1.20 times 10 to the fifth, and the unit will be volt over meters. This is our fourth answer, and that would be it. Thank you.